This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
In standard quantum mechanics, mass enters the math as a fixed parameter. We see this in the non-relativistic kinetic operator, where the variable m sits in the denominator of the kinetic term as an unchanging constant. In this formulation, mass is an uninterpreted inserted value. It is a primitive tag that ensures the equations match experimental results, but it offers no explanation for its own presence. This creates a gap in our physical ontology. The math can describe how a massive object moves under a force, but it cannot explain the structural origin of inertia itself. Point particle models rely on a lossy compression of reality. By reducing a particle to a zero-dimensional dot, they discard the internal physical structures that might account for its resistance to acceleration. When we treat mass as a fundamental given, we lose the ability to investigate its derivation. To understand the inertia, we have to look at the geometry standard models ignore. Fractal Quantum Particle Theory, or FQPT, replaces the primitive point with a different structure. It suggests that a particle is not a singular static object, but a process. Here, a particle is a stabilized equivalence class of structural states. It begins with a primordial seed state, psi 0, at a high energy scale. A recursive operator, f, acts on this seed, initiating transformations that unfold across multiple scales. In this framework, mass is the measurable inertial residue of that cross-scale stabilization. By tracking this entire recursive generation process, we can see exactly how abstract excitation energy transforms into the physical property we experience as inertia. This process is governed by a recursive generative law. Each new state in the sequence is a functional transformation of the previous one. The particle exists across a resolution ladder. It is not tied to a single static scale, but rather to the structured coherence across all layers of refinement. As the operator iterates, the seed generates discrete nested shells. These layers fold inward and outward, creating a complex, multi-scale body. At each of these layers, the system organizes excitation energy. The particle is the container for this organized energetic hierarchy. We monitor this using a weighted recursive energy functional. This check determines if the structural refinement is physically compressible into a single bounded identity. If the excitation were merely noise, this energy would diverge. It would lack the disciplined architecture required to maintain a persistent form across scales. Particle status is therefore earned through this energetic accumulation. It requires a specific compressible cross-scale geometry. As the iteration continues, a process called spectral compression begins. The diffuse recursive orbit starts to concentrate. The nested shells condense toward a stabilized boundary, reaching a limit known as the spectral attractor core. In this core, the variations between different scales are compacted. The instability of the initial excitation is squeezed into a coherent, persistent residue. Mathematically, the particle has reached its stable limit. The recursive sequence has converged onto a fixed point structure. This amber core represents a state of structural equilibrium. It is the stabilized version of the initial excitation. Without this convergence, the excitation would fail to individuate. It would remain a diffuse part of the background field rather than a distinct particle. Spectral compression provides the exact mechanism for turning a chaotic quantum event into a persistent, bounded physical entity. Because this attractor core is a compressed, stabilized body, it resists arbitrary spatial displacement. This geometric resistance is the source of inertia. Mass is not an added label. It is the physical difficulty of moving a stabilized recursive structure. This resistance is part of a larger identity functional, properties remaining invariant across scales. Within this bundle, spin represents the stabilized internal orientation law. Charge represents the recursive invariant of phase and topology, a stabilized circulation within the core. Mass is the energetic cost of locking these invariants together into a compressed spectral package. To change the motion of a particle, you must overcome this entire intertwined identity. That is why mass is experienced as inertia. The actual value of that mass depends on a property called stability depth. Stability depth measures how far the recursive refinement continues while maintaining its structural coherence. We compare particles by the depth of their recursive orbits. A shallow iteration produces a fragile core that deforms easily, translating to low effective mass. Conversely, a deep recursive orbit sustains a dense compressed identity, resisting displacement and yielding high effective mass. The effective mass of a particle scales in direct proportion to this depth of stabilization. The magnitude of mass is not an arbitrary parameter. It is a geometric measurement of how deeply a particle's identity is locked through recursive scale descent. To be useful, this derived mass must map back to the standard operator equations we use to describe quantum motion. We extract the effective mass variable from the core's stability data and place it into the fractal Hamiltonian. In the FQPT Schrodinger equation, this mass variable controls the kinetic response of the particle, determining how it propagates through space. The parameter m is now understood as the measurable representation of the deeper ontological compression. By bridging these two layers, we confirm that mass is a structural consequence of geometry, rather than a primitive constant. This stabilization process is not an isolated event. When we pull back, we see the particle as a local spectral attractor embedded within the larger energy flow of the universe, or delta core. The same laws of stabilization that build a single particle's core are at work across the entire spectral energy body of the cosmos. Having a stable, recursive identity is what makes a particle massive. The quantum particle is a localized substructure of a wider flow, and its inertia is the physical evidence of its cross-scale geometric coherence.